Our Earth is made up of huge plates that fit together like pieces of a puzzle. These plates, known as tectonic, are always moving. They have currents in the mantle beneath the Earth's crust that allow them to move in different directions, and as a result, living on a plate boundary is extremely dangerous.
Depending on which direction the plate is going, there are different types of plate boundaries. These are what cause hazards, such as tsunamis, huge walls of water caused by underwater earthquakes, volcanoes, and earthquakes. These are hazardous to people's health when they are near a population. Earthquakes are particularly dangerous, as this task requires us to investigate.
We began by investigating what structures have the capability to withstand earthquakes and how we were able to replicate this by creating a water tower made of straws that we could put to the test. Here's what we found out.
We gained a lot of inspiration from the world's largest earthquake test that occurred in Japan. As you can see, they built a full-size building, furnished it, and placed the building on an earthquake replicator. The house stayed steady and did not collapse like many buildings you see destroyed by earthquakes. This gave us the confidence and a few ideas about how to design our building. We both agreed that the cross-bracing technique was effective, and whilst one bar was slack, the other was tight and vice versa, which absorbed the shaking, allowing the building to stay still and therefore remain unaffected by smaller earthquakes.
Another popular technique is through the use of isolation bearings. They are small pivots which lay underneath the foundations of the building. As the earth underneath the pivots move, they counteract the movement, allowing the building to stay still. This is used frequently for skyscrapers and large buildings. We found this difficult to replicate with straws, so have decided to leave this out of our final water tower.
Weight distribution is essential in the creation of an earthquake-resistant building. It is important to remember that there is no such thing as an earthquake-proof building. An earthquake-resistant building is much more cracked. Heavier foundations make for stronger buildings. Lighter, higher levels do not move as easily and have less impact on the swaying of the building. One of the biggest challenges we faced was our building materials. We had no sellotape or glue, so we had to slide one of our straws inside the other. We used the cross-bracing technique on the base of the building to make it stronger. We then decided that we would use thick columns made of many straws that would join together to make a triangular structure and hang the water bucket in between that. This, however, was very difficult to make and ended up being an unsturdy structure. We then decided to make the columns only one straw thick, but make many of them. We joined the columns together to make the original triangular structure that we had planned, and then added a water basket in between. We hope this holds.